In this tutorial, I'm going to describe how you can automatically generate layouts using Mason. Here I have a folded dipole design with a LC balun that feeds into an antenna. So I'm going to take a look at my flag options that I've set up. And here I've turned on my pad's ASCII output, and I'm going to output a folded dipole.asc file. So if I run Mason, alright, so if I pop up my console, I can see that I've placed all of my transmission lines. I don't see any errors, and it's actually outputted two files. One of the files that it's outputted is folded underscore dipole.asc, and another one has this asc combined extra little bit, and we'll talk about the two different files that it's creating. So if I go into pads, which can read the asc file, and there is a demo version of this that'll work for many cases, and I want to import this folded dipole.asc file. So it's thrown some errors. It's telling me that I have some bad net connections, basically that I have nets defined, but it's only attached to one place, so it's deleting those as nets. So it's not really a bad error there. So what it's done is it's taken all of these microstrip line components and some of my 0402 components, and it's automatically placed them, put them in the right locations. And it's taken this other 0402 component and it's just sort of placed it but told me where they connect. So let's talk a little bit more about the models that I have in here and what it's doing. So it's taking all of these microstrip lines, and let's go ahead and just so we can see a difference next time, I'm going to make this line longer. So I just made that line, the next time I run it, it should go longer. So I have all these microstrip line structures, and I also have these LC components, but the package type that I use for this LC component is actually linked to this XML file, this 0402 XML file that's under lumped elements. For the microstrip, the package is this XML file that's under the microstrip folder, mline.xml. For the microstrip line, this is actually where both the electrical properties are defined and also the package information is defined. But for here, my package information is this XML file, but I'm actually using these touchstone models for my actual S parameter data. So let's pull up that 0402 component. It's got this PCB definition that describes the copper pieces, the locations of where these copper pieces touch each other, and the connection vectors. A bunch of different calculations. So if I have a component like this microstrip line, what I need is to define the two pieces of metal that make this up, the connection point where this guy is going to want to attach to here, and then some vector. So for this part of the T-junction, I have a connection point here and a vector that points out this way that needs to match up with this connection point and a vector that points up that way. So I'm going to go ahead and also point out that these 0402 components, because they're XML files that have a connection point and the vector defined, it's able to automatically place them. But this inductor I've defined just to be a standard 0402 dumb model that you could find in, that's just the default library component that PADS has. So PADS itself, it knows what an 0402 is, but Mason can't automatically lay it out in the right place. So we can fix that in some cases if we build up a smart model and have it automatically placed. So let's go ahead and do that. File, import. We have these errors again, And here we see this line has become much longer. It's now the 500 mils instead of the 100 mils, and then it's automatically placed that 0402 component for us. Now, one of the things is, both of these are supposed to attach to ground, but we don't actually have a net name associated with them. And the problem is, we've used this RF ground notation, and you can find an RF ground off of the Mason library. That's where I place it. But this RF ground could actually be a DC voltage. A 3 volt line is also considered an RF ground. So it doesn't actually assume anything for the net name for these components. If you want to have something that is both an RF ground and a DC ground, you want to use this power component with the power voltage defined to be ground. And I've modified TinyCAD to automatically assume ground. So now we actually have a net name defined. You could also define the net names if you want using labels. So if you're trying to pull in a schematic like this and you want to be able to link it to like a DX Designer schematic, you can do that by labeling the nets instead of using the automatic ones. And the other, delete the old artwork and import the new artwork. And now we've gotten rid of the two connections that were ground, but they were not attached to each other because they weren't actually ground nets. So now we just have one bad connection. That's our input. So let me close this, and now both of these are defined to be ground. This one would be in, except it was a single net, so it deleted that name. So, but really, if you want to attach something like this into a schematic, what you really would like to do is have your DX Designer have a schematic part for this structure, and you would want to be able to reference just a single item. So before, we had lots of individual microstrip lines and 0402 components that were just placed in the correct location. But what we could also do is we can import this AskCombined file. This AskCombined file is actually just one single structure. And the convenience is you can attach this. Add a new component. I can link these together and route these, and it'll set up the connection points appropriately. The problem is my grounds. So it's created this structure, but the only place that I can attach to this structure is where I had a port. So I need to cheat a little bit here. So what I'm going to do is modify the schematic one more time. And I'm going to change these grounds to be ports. Specifically, ports with a very low impedance. So for simulation purposes, this will work reasonably well, although to be honest, I'm probably going to avoid doing this trick while I'm doing simulations, and instead I'm just going to do this at the very end when I generate my design. But now, it's going to set up that point, and this point, and this point to be terminals I can connect to. And I'm going to go ahead you can see that reran, didn't have any problems. I'm going to load up paths, file, import this ASC combined, and now when I select these terminals, I have 3 different terminals I can select. You have to be careful with your schematic that right now that's port 1, that's port 2, and that's port 3.